need to do this Instagram thing.
Oh, it's live. It says it.
Okay, excellent. I'm glad it's live. I, as usual, am unprepared and I'm getting better, but I'm still not. I wouldn't say I'm an Emmy winning or whatever they do for internet productions producer just quite yet. It just took me a really long time to figure out how to make it work on my Instagram. So, hi, people on Instagram, all 5 of you, if you're there. Um, anyways, welcome to Taking Shots. This is a show that normally I do every Friday afternoon, sort of a happy hour kind of what's been horrible in public health this week kind of show with my co-host Jessica Malati Rivera, who is on vacation this week. So I'm very fortunate in that I have an embarrassment of riches of really smart friends who also can come on and talk at an expert level about these topics. So I'd like to welcome my guest co-host, Dr. Juliet Morrison. She is a virologist and educator. We also, full disclosure, did our PhDs in the same lab and have pretty much like worked together through the majority of different jobs that we've had over the course of our careers at different institutions. So we're longtime friends and collaborators. But welcome, Juliet. I'm really glad that you could join us today.
Thank you, Angie. I really appreciate it. I'm very excited to be here, and I'm looking forward to talking about measles and public health and all that good stuff.
Yeah, well, Juliet, there's nobody that I like to talk about viruses more with, except for possibly our PhD mentor. I do like to talk to him
He
about
does love
viruses
those.
as well.
He does love them. Yeah.
But we've talked about viruses for going on more than 2 decades together now. And so I thought, what a great way to welcome you to the show as a guest co-host and talk about a virus that neither of us have ever worked on before, because I don't know about you, but the reason I've never really had much of an interest in measles virus is because I didn't ever really think that measles virus was going to be relevant to me as somebody who studies emerging viruses that actually still pose a public health threat because the vaccine is so effective.
Yeah. It's and it is an excellent vaccine. Like we haven't even had to change it for forever. Like it's just been a really good vaccine. But yeah, I would never have expected measles to be an issue. So yeah, it was not on my list of viruses to work on. And I used to work on polio virus, right? Like where people would say to me, "Oh, isn't that extinct?" I'm like, no, it is not extinct. It is actually still a serious concern. It's really hurting people. But I understand the sentiment. But I get what you're saying, Angie, because for real, like who would have thought that measles virus would be so much more relevant now? And it's actually becoming super scary, actually.
We'd probably be in the same position having to learn about polio if we'd done our PhDs in a morbillivirus lab. But I feel that unfortunately our polio knowledge as well is going to probably come in handy in the coming months and years because vaccination uptake across the boards has been down. And so that's what I really wanted to kind of start off with about measles today is sort of the intersection of what's happened and what's caused this huge outbreak, but also kind of what we're doing about it now. Like why are we still having this when we do have this vaccine? Because this is not something, and I think a lot of people like to just say, oh, okay, it's the new management in charge of our public health system that's caused this, but this precedes that by a long time. I mean, these outbreaks, these outbreaks that are happening in school age children. So these are parents who decided not to vaccinate their kids, 6, 7, 8 years ago. Different administrations. I mean, the anti-vax movement has been really, really working at their objective for a very long time, and it's working. And people across the boards are turning down vaccination. And so that's why we find ourselves in this position that we're in now with so many measles cases. I've been saying it for a long time, like measles will be first and polio will be worse. Because I do think that measles is such a contagious virus that it's very, very easy for it to spread if it
and it will.
A little spark hits a community. with enough people that are unvaccinated, it's going to take off. Polio is a little harder. And polio doesn't cause poliomyelitis in every single person that gets infected with polio virus. So you won't see as many cases as quickly, but I think it will come. And unfortunately, when it does, it'll be good, I guess, that we know a lot about polio, because there aren't that many people who do, unfortunately. And that's
Yeah,
kind of,
like, I mean, it's something that like has been kind of relegated to history. Obviously, there are still people who study polio, but they also study other viruses related to polio because everyone has figured that working on polio is, like it will be eradicated eventually. But now I'm starting to worry because I, if with the measles thing and everything else, like it's probably, if nobody's vaccinating, we're going to see this return of these childhood diseases that killed so many people or maimed them, disabled them in some way. And people are going to be so shocked because they have never actually understood how terrible these diseases were.
yeah, I mean, that's one of the biggest problems, is that people have no appreciation for the fact that these aren't just like natural things that people used to find to be an inconvenience. These were things that actually killed sometimes multiple children in families. And it's heartbreaking to me, having seen a mouse with polio. I can't imagine seeing a child with polio. I know that people, I've met polio survivors, and I've seen, certainly in countries where people still routinely get polio, pictures of that, and I just can't imagine
No, it's awful.
making the choice to bring that back. And same thing with measles. I mean, measles, doesn't, you're not going to spend the rest of your life in an iron lung if you recover from measles. I've talked to my parents about it a lot of times when they had measles when they were kids. The fact that they had measles when they were kids and they survived, and they didn't have any disabilities, and they didn't have SSPE or anything that comes with it, is irrelevant to them. They were like, I hated having measles. And so the fact that it was a no-brainer, like they didn't even consider not vaccinating me against measles, because even though it didn't kill them, they didn't want me
Yeah,
to get it. Like, it still sucked.
it
And I
still
think
sucked. Exactly. Like I still have from chicken pox. I got chicken pox because back then there was no chicken pox vaccine. And
same.
I still have scars from it. And I just remember it being an awful, awful, itchy disease. I'm like, why would you want this for your child when they could just have a vaccine and then never have a whole bunch of scars that they might slightly be embarrassed about? I mean,
Yeah.
come on, man. Parents are being ridiculous.
Well, I think that the problem is that parents are being fooled, and some of
Yeah.
the other problem is that, you kind of nailed it when you're talking about some of the older issues with polio eradication. Like, so I agree with you. The reason I did my PhD on rhinovirus instead of polio is that basically I wouldn't be able to take that research with me anywhere. I wouldn't be able to continue that research because we thought polio was going to be eradicated. Now there's no question it's not going to be anytime soon, anyways. I think. But we're at the point where we could have started to have a conversation about global eradication of measles, because measles is actually a candidate for this. The vaccine works extremely well. It doesn't have a known animal reservoir. The challenge is getting everybody immunized against
Yeah.
measles. And so that's why we haven't been able to eradicate measles. But now we're going backwards on that too. And that's what I also really wanted to talk about. We haven't devoted enough resources to this for good reason. We thought that measles was essential. Measles was eliminated in the US for
It
20
was in
years.
the 2000.
So
Yeah.
why would we invest a ton of money into doing things like genomic epidemiology in the case of giant measles outbreaks, because we weren't having any until now? Well, reporting that came out yesterday from Amy Maxman at KFF Health News said that basically the CDC and other state health departments have been sequencing all of these whole measles genomes, right? Now, with measles, the way that they've historically done diagnostics is they do a PCR assay. So for everybody watching, this is essentially a molecular assay. You're probably familiar with the term from COVID, but it's essentially like a photocopy of a very small piece of specific DNA or RNA. And when you photocopy that up, you know that it's there. So you can diagnose a virus that way. And you can sequence that piece that you photocopy up and tell what it is. And so for measles, they use, I can't remember which viral gene it's from, but they use a fairly conserved part of the genome that allows them to distinguish genotype, but it doesn't actually allow them to do really genomic epidemiology, which is where you can use the sequence to actually trace the infection and see where it's gone. So historically, they've always done this PCR. They started to do the whole genome sequencing then because we've done this with COVID. We do it with flu. Like it's really an important way for tracking outbreaks, but none of the data was available. Now, I was really suspicious about this like about a month ago because the then principal deputy director of the CDC, Ralph Abraham, gave a little press conference the day that we were set to lose elimination status. So I guess it was a couple months ago in January. But he basically was like, oh, we don't think that these outbreaks are related to each other. And now I'm starting to think, like, I wonder if that's why none of these whole genome sequences were available, because you could use those whole genome sequences
to tell,
to
yes.
trace from Texas to, you know, Arizona and Utah and all in South Carolina and Washington and all the other states. So now some of these whole genome sequences finally, after all this time, are starting to become available. And there's still gaps in the data. I talked to one of my colleagues who's not involved in the work at all, but who is an evolutionary virologist, Christian Anderson, who kind of is one of the people who invented this field of genomic epidemiology. And I said, can we tell? And basically, we're pretty close to being able to confirm that elimination status has been lost. But, you know, I don't know that that's the whole story either, right? Like, I'm not sure that it is like a cover up, and how much of it, I guess, is trying to conceal the fact that we've lost elimination status through poor responses, and how much of it is the fact that our functional capacity is so degraded that we actually can't effectively respond to this, and we actually can't get that data.
So I guess I have a question. Like, what are the steps to, I mean, I understand the steps to get to elimination status, but like, how do you lose it? And how does this part that you're talking about contribute to us losing it? Or, you know, like, describe it for me. So if I'm asking the question, I know other people are probably asking the question. I say that to my students all the time.
That is a great question. And that is why I am listed as a virologist and you are listed as a virologist and educator. Because you do keep in mind that educational component. That's a fantastic question. So elimination status is determined by a period of time in which there is no endemic transmission of that pathogen. Loss of elimination status is a year with endemic transmission. So Canada, for example, lost its elimination status. And since Canada's in the Americas, so did all of the Americas. And this is determined by PAHO, which is the Pan American Health Organization. It's basically the WHO subdivision for North and South America. And you know, everything in between, all of Central American countries. Basically, a bunch of countries are going to lose elimination status now because there have been huge measles outbreaks all over the place. In Mexico, in Canada, in the US, throughout Central America, in several South American countries. So all of these places are going to lose their elimination status. But the way you determine if there has been endemic transmission for a year or more is you either use epidemiological data, so the good old fashioned shoe leather kind of epidemiology where you're out contact tracing, you're out finding, you know, chains of transmission and tracing them around. That hasn't been done in the US, like for a lot of these outbreaks, because there's a lot of variability from state to state. And this is where the loss of capacity in the government comes in as well.
Okay.
So we might not have some of that epi data that has historically been used. So what we would have to use instead is genomic data. And part of it is if the US government, and I'm not sure they are going to, it's really confusing right now because with, you know, the elections coming up, the attitude towards public health, it's not quite clear what the path forward is for HHS. So I'm not sure how they're going to pursue this. But if they wanted to, they could argue that we haven't lost elimination status, which I think is just absolutely absurd because we've had 1,600 measles cases this year and it's the beginning of April. I mean, that is ridiculous.
No, it's really ridiculous.
Higher than
And
it's
that
been in
cannot just
decades.
all be importation, considering that like people are not even traveling here.
But that's the argument,
kind of
Juliet.
ridiculous.
That's the
No,
argument.
that
They're
has to
making
be local spread.
they are
Mhm.
making the argument that all of these outbreaks are individually imported. So each of the outbreaks is local spread. It's not just all importation cases, but they get started by somebody bringing it in from another country and not another state. And so that's why they're saying, but you know what? It gets even more confusing because a lot of this outbreak was started in the Mennonite community, um, which many Mennonites don't
Yeah.
vaccinate, not
Mhm.
all. But there are large Mennonite communities, including here, actually, where I live in the Canadian prairies. There are a number of Mennonite communities as well. And travel back and forth between different Mennonite communities is actually how this is spread throughout North America.
Oh,
Um,
wow. Okay.
yeah, so this started off at a family gathering in Atlantic Canada, spread to Ontario. From Ontario is how it spread to Texas. It was people visiting their relatives, essentially. And then from Texas, it spread into Mexico from also people, I believe, who lived in Texas but had business interests in Mexico. And there's also a large Mennonite community there.
Yep.
The situation in Mexico has been exacerbated, and some of this through Think Global Health, which is the Council for Foreign Relations publication about global health, is edited by our former colleague and classmate at Columbia, Sikan Akpan. And they've had some really interesting
I've gone to
reporting.
school with him twice, both at Bard and Columbia.
That's right. That's right.
Mhm.
So you're double Sikan's former classmate.
Yeah.
But
Mhm.
they've done some really, really fantastic work to actually look at some of the reasons why there were so many cases in Mexico, because there have been a ton of cases, more than in Canada or in the US. The US is actually coming in third after Canada and Mexico right now. In Mexico, besides anti-vax stuff, which is everywhere and in different ways in different places, but it's everywhere. In Mexico, they also had a problem with supply chain, like with getting the vaccine.
Oh,
And so
okay.
they've had a lot of deaths in older people because there was in the entire state of, I think it was Chihuahua, they were not able to actually vaccinate a number of children like for 1 or 2 years because of these shortages. So it wasn't actually an anti-vax thing. It was just that there was a
Okay, so
gap
then,
in
oh my
vaccination.
God, and I don't know if I'm like being like, like nerdy me or anything, but like, why is that? Like, why is there this supply chain shortage for Mexico, which I consider to be actually a pretty developed country?
So
Um,
that question I can't answer for you
okay,
because it probably has something to do, it has less to do with manufacturing probably and more to do with purchasing. So in Canada and in the US, it works the same but very different between the two of them. In the US and Canada, both, the federal government buys large doses of these essential vaccines that everybody uses. So it's not like you are buying this vaccine from Merck, the MMR. You're buying it or you're getting it from the federal government who's already bought a whole bunch of it from Merck. And so that's the way vaccines like that, essential vaccines that are recommended by the CDC for everybody, are purchased. The same is true for Canada. I don't know about Mexico, but probably where the government is buying the vaccine doses. But in Canada, what's different is that our healthcare is administered provincially. So we don't have a federal healthcare system, but we also don't have private insurance. So then the provinces have to negotiate with the government to buy it. And I kind of wonder if something like that didn't affect this, where, a state was negotiating to get their vaccine doses and something happened and it didn't work out. But I
right.
don't think it's a high income versus low income. I think it's one of these supply chain things that can happen
Okay.
anywhere. But in any case, like that has driven a lot of these cases. And I think one of the things that, a lot of people need to understand, and this is why rather than sit around speculating whether, the government's trying to cover it up so that we can keep elimination status, even though it's pretty obvious that it's hell and gone. I mean, I don't know how you could argue that we still have measles eliminated with 1,600 cases in 4 months.
No,
It's
it's
just
ridiculous. There's
insane.
obviously a whole bunch of local spread. That's no.
I mean, to
Come on.
me, it just really seems like that, we are in serious trouble because our government, our CDC, our public health system is not able to respond to these things. And for whatever the reason, which is loss of personnel, loss of funding, primarily, political environment that makes it difficult for them to operate in, and I guess a public sentiment that's very anti-public health, it makes it very, very difficult to actually carry out basic outbreak responses. And I don't know if you have any thoughts on like how you could get around that. I mean, in so many cases historically, academics have jumped in to try to pick up the slack. I know during the COVID pandemic, both of us basically, and all of our colleagues, we all just did whatever was
We
needed.
did stuff, yeah. Like
We
I
did
helped set up
stuff.
the COVID-19 like testing facility at UCR. Like that was part of like what I did.
Yeah.
There are pictures. um,
We did stuff like that we could.
yeah,
We saw that there was stuff that needed to be
to be
done.
done, and we
There's
did
a
it.
lot of
Yes.
stuff that needed to be done, and so we figured out the one thing that we could do, and we usually did it. I mean, most of us, I think, tried to do that during the pandemic. And I think people would do that today, but now we don't have that option because so many people are not able to do that, and the people in the government who were there originally to coordinate those relationships are gone. And I mean,
Yeah.
it really scares me because of, how transmissible something like measles is. How can you stand up an immunization campaign to respond to a giant expanding outbreak with like, 1/10 of the resources?
No, it's no, it's terrifying. It is genuinely terrifying. And then it's going to take us like what, 5, 10, 15, 20 years to then have some like economist or epidemiologist do a study to show that all of these people who have like encephalitis and are like dying, it's because of this one like blip that we had at this point in time because people were not taking their measles vaccines. Like it's kind of crazy.
I'm worried that
Um,
it's not gonna be a blip. Do you think it's gonna be a blip?
I don't know. I think eventually people get tired of their children dying.
How
So
long do you
I
think it'll take, though? I mean, I guess my other concern is that these genomes tell me another thing, and that is that whatever the reason, we're collecting data that's important and that's needed as rapidly as possible, and it's not coming out. So I was just writing a Substack article about the preprint that I just, I'm a very middle author contributed to. I like contributed some words mostly to this preprint, but it's to look at the origins of H5N1 in dairy cattle in the US and
mm,
all of the spillovers that have occurred. And I mean, I'm just, thinking about this. One of the big problems we had with this was that the USDA wasn't sharing metadata associated with these sequences. So we weren't able to do like the phylogenetic, like temporal tracing of the sequences to see like when it emerged in the cattle. And, that was an example of a time when we had a lot of scientists with that expertise who were able to step in and sort of do that because the data was actually still being reported. The metadata wasn't being associated with it, but we did all this detective work and we managed to extract the metadata from a slide that was presented by the USDA's chief veterinarian in a webinar. And we were able to do the analysis and confirm the USDA's results. As a result, the USDA has gotten a little bit better about regularly posting their sequence metadata. But I don't know that we have the capacity to do that kind of thing anymore. That was an example of the USDA's processes being somewhat antiquated, where they had all these checks and things they had to do before releasing the
mm-hmm.
metadata. Now it's like, is there anybody to do that stuff? I mean, I know a lot of my colleagues from USDA are still there, But USDA APHIS, for example, has lost 1,300 people. That's like a third
Oh
of their
my
workforce.
God, that's a lot of
It's a
people.
ton of people. And I mean, those are the people who are responsible for doing all of our animal health inspections, all of our plant health inspections. Like they are responsible for making sure that our agricultural health is sustainable and
Yeah.
protected. It's really,
I
really
mean that
alarming.
that go- and that feeds right into, I don't know, food security. Like that's
Sure does.
so scary for me. You know, you know me, how I love my, like, well, I used to before this, but you know, like I love my sort of like George Orwellian sort of, you know, dystopian things. But no, that's actually terrifying. Like
Yeah,
I
the
can't imagine.
dystopian fiction is a lot less fun to read these days now that it feels like
Yeah,
nonfiction,
yeah.
with less useful technology sometimes.
But it's like, you know, the food thing actually really does worry me, because if we don't have people making sure that, like, you know, things are sustainable and also that things are safe,
Yeah.
like it's scary.
Well, that's it. And I mean, there's a lot of leadership changes happening right now. And one of the things I worry about a lot, it's not so much with food, but it is with regard to health. And it does relate to food security because it's the institute that's partly in charge of our nutritional health. And that is that the CDC has actually no director at all. The CDC has not had a permanent director since Susan Moneros was fired in August, and Jay Bhattacharya most recently was the acting director. He still sort of is the acting director. They say that he's fulfilling that role, but now he's like lowercase acting, uppercase acting director, because legally he's not allowed to use the title of acting director because he's actually aged out of the deadline that's determined by the Federal Vacancies Act of 1998. So the CDC doesn't have actually a dedicated leader. And I mean, the same is true. The FDA does have an FDA commissioner, but it makes me really, really worried that the loss of capacity at all of these agencies and the fact that so much senior career leadership experience has been lost. So people who have who've not just come in with this administration, but people who've been working at these agencies for decades and understand actually how these things work scientifically, what needs to happen in an outbreak scenario like this. Those people, if they're not there, what are we going to do when we start also having polio outbreaks? I mean, I just saw a thing today that there's been a huge increase in Hib cases, which is bacterial disease that affects babies and causes them these horrible like breathing
Yeah.
problems. Diphtheria is increasing. I mean, infant
I,
tetanus is
I
increasing, and
know. I
I just
know.
I'm
I
beside
just can't.
myself that we suddenly are in this situation that's incredibly alarming, and now we don't have like the public health infrastructure to respond to it. It's like, this show's called Taking Shots, and it's an entendre about vaccination as well as like
Yeah.
dunking on our enemies. But theoretically, we were like, we're going to have drinks when we do the show. And now every time, like, I don't know that we've ever had drinks on the show. It's like, it's never fun.
It's never, yeah, exactly. This is just too serious. It's like, oh God, this is awful.
It's
No,
really,
I mean, like kids are like dying from whooping cough, like in America. Like, what is this? What is going on here? Like, I don't understand. Like, save the children. Like, I thought at least that was sacred for people. And people are not vaccinating anymore. And I know it's not their fault. I mean, it is partly their fault because, like, you need to like also have some responsibility to do
people
your
have agency
research.
and choice. Yeah,
Exactly.
people are not morons.
Right. But I also know that there is a whole, you know, group of people who are really trying to manipulate other people into making these terrible choices. Nonetheless, people need to educate themselves. I Yeah, because this is getting out of control. It's
Yeah, so
already out of control. We can't have measles.
no. And I mean, this is, I think, what you were saying at the very beginning, Juliet, that people don't know what these diseases were like. I mean, this is the real problem that we face, I think, is one of communication and education. Like we try to educate people, but if people don't want to be educated, we have to find other ways to get information across, because what's happening now is we are in an information landscape where the anti-vax movement has been exceptionally good at this, where effectively information has been weaponized. And if you have the greatest reach, you will have the greatest power and influence, essentially. This is why, and hey, everybody, including my haters who might be watching, who say that, oh, look, I'm trying to become a famous influencer. No, this is actually why I'm doing more of these Substack lives and stuff, though, because I think that right now it is really, really important for people to have sources of information that are reliable and that are people that they feel like they know who they are and that they can trust in their expertise, because there are so many people who have no expertise and who have very, very bad motives. And we have seen it time and time again with the anti-vaccine movement, where it's just one thing after another. It starts off with MMR vaccine causes autism, and that turns into vaccines can cause these injuries that result in lifetime sort of disability of all kinds. They cause asthma. They have fetal body parts in them. They have, there are so many different lies about that. They cause people to die suddenly. I mean, all of these lies about vaccines, they're all lies, but the fact is they get repeated over and over again so many times that people think that they're true. And so this is actually why I've been just focusing a lot on, like, what is the evidence? Now, it's impossible for me to talk about the evidence without injecting my opinions into it. And that's just one of my flaws as a human being and also part of my charm. But I wanted to kind of finish this episode off by talking about another topic that's sort of adjacent to this, but that suffers from the very same problem. And that's the origins of the SARS-2 pandemic. So this past whole week, Juliet, I've been going around with the lab leakers once again, which is, the curse that I have chosen in my life by participating in this research. But I think that it's really...
No, I think it's a good thing that you did it, but oh my God, yeah. Like I saw that and I was like, 10-foot pole, no thank you. Like,
I mean,
give an opinion on that, because so many people were so adamant. Like they were so happy and excited to somehow make this China's fault. Like, and it's like, it's so obvious. Yeah.
That's
like
how it started,
yeah.
but now it's turned into something else. And I think that's what's so frustrating for me, is that through all of this, and when it started, I saw, oh yeah, this is China's fault. But I also saw a lot of people saying a lot of bullshit about virology that wasn't true at all.
That's true.
And, one thing that the lab leak people accuse me of all sorts of stuff. And one of them is that, and actually not just me, but our entire field, is that virologists don't want it to be a lab leak because we think that would automatically mean no more virology. Party's over. No more dangerous gain of function research. No more juicing up viruses, Juliet. Our good old days of like, can I out gain of function you, are over.
Oh my God. What will we do?
That would have been a losing contest.
I don't know, like what, make vaccines, like take care of the world? Like, no.
I bet, if we had a gain of function off, you'd be cloning stuff and I'd be serially passaging it. Let's see who wins. No, we actually never did anything like that, because virologists actually don't do that. Like that. We don't do pointless experiments, and we don't try to make viruses more dangerous just for the sake of doing it. So yes, that did bother me. And that is the one thing that lab leakers accuse me of that is kind of true. I definitely did kind of get into this to defend virology, because none of the descriptions of this virology were anything that I was familiar with in terms of how I approach my work, or in terms of how any of my colleagues approach their work. So that's kind of how I got into it. But what really bugs me about this is that people say all this stuff over and over. I mean, there's so many lab leak hypotheses. It's like, oh, it was made at Fort Detrick, and then it was at the military games. Oh, it was vaping in the U.S. Like, remember the vaping disease that everybody got in 2019?
Yeah,
that was COVID.
Vaping disease.
It was a neurocognitive bioweapon developed by the PLA, which is what literally the former ASPR, Bob Kadlec, proposed. There have been so many different conspiracy theories about it, but the most popular one and the one that's politically useful right now is the Tony Fauci funded gain of function research at the Wuhan Institute of Virology. They made COVID and pandemic.
But I think for me, I mean, the question would be like, okay, if somebody were trying to make this into some sort of like global bioweapon, like why would you make it so transmissible and you can't target it? Like
It
this is
only
just
kills old
like what
people.
kind of stupid science is that? And it doesn't kill everybody. Like it's just dumb.
No. That's why it's a neurocognitive bioweapon, Juliet. So it's not a conventional one. It's not trying to kill soldiers. That's how because I was like, what is stupid bioweapon? It only kills
Yeah,
old
it
and
just
sick
sounds
people.
so dumb.
Like, and it's really transmissible and you can't vaccinate against it, like
Yeah.
effectively. Like, why
Who
would
would
you make
make
that into a
this?
bioweapon? But no, the idea is that it's gonna disrupt society by giving everybody long COVID is the deal. Yeah.
I
So
mean, yeah. Well, I mean, long COVID is a thing. So,
it is a
like,
thing and it's been incredibly disruptive to society, but
yeah.
boy, did that backfire, because I'm pretty sure it was pretty disruptive to China too.
Yeah,
And
just everybody
but
has
see,
been
some of this,
disrupted.
so much of this stuff is like, oh, what if, what if, what if? Like all the lab leak stuff is what if. It's like, what if like they were secretly making chimeric viruses there? I know that they only made a few like reverse genetic systems that worked. And boy, do I relate to that, because I only ever managed to make one and that was fucking hard. I'm just not very good at cloning. I'm just mediocre at it. It's okay. I'm cool with it, but
we
these
all have
lab leak,
our talents.
oh, the lab leak people though make it I love it. They think I'm incompetent at everything except for like cloning and bioterrorism. It's like I could just like sneak off into my lab and just like whip up a poor man's nuke, like biological nuke, and just like set it free because I feel like it. Absolutely. Well, first of all, I wouldn't do
No,
that.
that's not
But
true.
second of all,
Yeah,
no, actually, even like somebody like me or you or anybody who has
it just
decades of
doesn't work
virology
that
experience
way.
doesn't work that way. You literally could not do that. But that's what it's just like, what if that happened? What if that happened? So I'm just like, these days and this past week, I just kind of lost it because Matt Ridley, this guy from the UK who has no relevant expertise, spoke at NIH, gave an hour-long talk about his book, which is a popular book that he wrote with his fellow co-conspiracy theorist. And basically, it says that conspiracy theory. And, it's all kinds of insinuations like this happened. So what if this happened? This database went offline. What if it had the secret evidence that they had a progenitor virus with the WIV?
That's a lot of
It's a lot of what if, but
speculation, and it's like at that point it's like fiction and fantasy.
right. But this is why it's really a huge problem, because it is fiction and fantasy. It's a lie. And it's also directly contradicting work that I have published that has been peer reviewed and published in shitty journals like Science and Cell. Like these are, by the way, for everybody
By the
watching.
way, yes, Cell and Science.
There
They're
are
very,
three
very
top
good
journals in the world: Science, Nature, and
Yeah.
Cell. So
Yeah.
Science and Cell are two of those. And all of our papers, for the most part, the big ones, have all been published in Science or Cell. And so, it's absurd that like these dudes, like who have no qualifications whatsoever, and they're primarily dudes, although there are some exceptions. They just basically shoot their mouth off with their opinions. Like, what if this happened? I'm just asking questions here. I'm just jacking off. That's what we call just asking questions. But asking questions that are actually making accusations. And so I just took it upon myself this week to write. I wrote a very long Substack article about it, but the pieces of evidence as to why it wasn't a lab leak. And Juliet, I don't think I've actually ever talked to you about our findings, so I'm just going to run them by you right now.
Okay.
What we did was in 2021, like our whole group, the Zooinati, me and the people who ended up writing these papers with me, we all kind of got together because of Twitter. Actually, we were all really sick of like the lab leak bullshit. And so we all started chatting, and we all decided that we were going to write a review paper, which ended up being published in Cell. And while we were doing this, we were going over like the WHO mission report, and we saw that all of the early cases like were around the market, and excess mortality branched out from the north side of the Yangtze River, which runs through Wuhan, and is where the market is, compared to the south side, which is where the lab is. So we saw like all the death and all of the hospitalizations and all of the COVID cases like happening around the market, not around the lab on the other side of the river. So we did a more rigorous analysis and got actual statisticians involved. And it turns out that that was a really significant thing. So that's the first thing. All these early cases, whether they shopped at the market or had any kind of link to it or not, are significantly associated with the market and not the lab. So then we looked inside the market, and we had these results that had leaked from a Chinese CDC study where they did all this environmental sampling, and we found where they had detected SARS-2 throughout the market. And we found that in the southwestern corner, that was where most of the positives were clustered. It turns out in that southwestern corner, that's where the animals were sold. And we did find documentary evidence of this, but also our co-author, Eddie Holmes, visited there in 2014 because his colleagues in China took him there as an example of a place where the next pandemic might start because of the live animal sales that were happening there. And Eddie took a picture of a raccoon dog on top of like a cage full of birds. And that stall later had 5 positive samples for SARS-2. And then, Juliet, it was crazy. This is the third piece of evidence. We got the raw sequencing data from those environmental samples. And we found out that at that stall, they were still selling raccoon dogs there because the day after we got these data, my co-author assembled an entire mitochondrial genome from a raccoon dog from Eddie's stall. So it was, it was pretty crazy. Like we found the virus, the animals, all in the same corner of the market. There was no other cases in Wuhan. But the fourth piece of evidence that I think is really damning for the lab leak is the fact that there were 2 spillovers. So like the more phylogenetically inclined people in our group of collaborators than me, I was not an author on this paper, but they ran this model where they basically simulated all these different phylogenetic outbreak scenarios. And they found that the only one that worked, because there were 2 lineages of the virus at the market, was 2 separate spillovers, essentially. There were no intermediates detected at any point in the human population. So it didn't get into humans and then diversify into 2 lineages. It was 2 lineages when it got into humans. And we know this from all of the downstream phylogenetic data that exists. So those 2 spillovers.
I'm not a geneticist or anything like that. So I guess my question to you would be like, how does one tell that it was that diverged before it jumped into the human population? Like how can you tell it's like 2 separate events versus the
you build trees and you do all these simulations, and I am not the expert. I can hook you up with one of my co-authors if you want to know all the gory technical details. But basically, the long story short of it is that you have to be able to make phylogenetic trees that explain all of the downstream data. So as lineage A and B continued to evolve, we don't have as much upstream data, right? But as they continued to evolve, we also have so many sequences from SARS-2 at this point. We can determine if there are these transitional phenotypes because the lineages differ by only 2 nucleotides. So finding one nucleotide change, a transitional form between the 2, would be one way to tell that it had diverged in humans. But there's no evidence of that. And in fact, there's more papers that I was also not an author on that get into this in a much more technically detailed way. And I'm not the one to explain those beyond like the high level explanation I just gave. But the bottom line,
that was great. Like that's what I wanted to know. Yeah.
Yeah. The bottom line is that there were 2 spillovers that happened about 1 to 2 weeks apart. So in order for that to be a lab leak, you would have to have one person at the lab get infected with lineage B, go straight to the market without infecting anybody else along the way. And it's about a 30-minute train ride. It's like, it's like getting on the A train and going downtown. I mean, it's not short. You know, you would
Mm-hmm.
encounter a lot of other people. It's a city of 11 million people.
Yeah.
So you would encounter a lot of other people, and how do you not infect anybody along the way? You'd then have to only infect people at the market, maybe, I guess, animals, and then not infect anybody else anywhere else in the city afterwards. And then 1 to 2 weeks later, the same exact thing would have to happen independently with lineage A. Um, you know, that's possible, I guess, but that's not plausible. And I was talking to Vincent, our PhD mentor, the other night about this, and like I literally just cannot imagine a scenario like that happening at all in my head. I don't know how you would be able to infect yourself in the lab, and your practices are so bad and sloppy that, and, you know, I'm talking to Vincent, who came up in, you know, a different time for biosafety, that's for sure. Like, people were eating and smoking in the lab and using radiation and stuff.
And
You
not
know, I
wearing
mean,
gloves.
not wearing gloves, like, it just, you know, totally different attitude back in the day about biosafety. And I mean, Vincent was like, yeah, even then, like, you would not see some, I can't even imagine something like that. You know, historically, you look at lab acquired infections and they don't occur like this. It's not really very possible at all. I mean, or like, what's more likely than that? That it diversified in animals, and then it emerged into people within about 2 weeks from two different, you know, animals, or the same animal maybe, or whatever, but two different people started two different, essentially, chains of transmission, just like SARS-1 did, by the way, in the markets of Guangzhou and Foshan, where literally it emerged under the same exact circumstances with the live
Mm-hmm.
animal trade. So it's to me, you know, that the simplest explanation in this case, old Occam's razor, is really important. And I think the two spillover thing really is an important piece of evidence. But the final piece of evidence is just that there's only one piece of evidence for the lab leak, and that is that the pandemic started in Wuhan and there's a lab there. That's it. Like, there is no
Yeah.
evidence for the lab leak. Everything else is
Agreed.
like,
Yeah,
what
like
if
that
this happened?
was just very like I felt like that was just very targeted in a way. And I have no skin in this game because I actually really don't care.
Yeah, I know you don't. That's why
but
your
but I
opinion
know I'm
actually
serious.
matters
But
the
what I
most.
will say is that no, it makes like it really was just grasping at stuff, and like most things are not lab leaks. Most things are zoonotic things. So yeah, like I that was never something that I jumped on the idea of this being some you know lab in Wuhan doing something sketchy or sloppy.
Yeah, you
Honestly,
know, I think the thing that bothers me the most is that the lab leak people keep saying that even, you know, zoonotic origin or market origin virologists, like, don't think this is, you know, a slam dunk or whatever, the smoking gun. Um, and I mean, I can't even begin to tell you how dumb some of this like discourse has been, Juliet. Do you know that there are two arginine codons in the furin cleavage site of SARS coronavirus 2 that are CGG? And, you know, there's like six, I think, arginine codons, and CGG is not one of the most common ones. David Baltimore was shooting off at the hip in, like, I don't know, June of 2021 or something, and said that, or maybe it was even before that, said that the two CGG codons in a row were a smoking gun. And like, I'm still hearing people talk about these stupid double CGGs as, like, you know, the equivalent of like Shou Zhengli was here. It's so
no,
stupid.
it's ridiculous.
Have
No,
you
that
ever engineered? Actually, I wanted to ask you this. I certainly haven't, but have you ever engineered in like a signature codon?
no, I have not done that. Like that is not usually what I am aiming to do when I
Have you
do
ever
my stuff.
considered having a signature
A
codon?
signature? No,
Like a signature,
not for my
I mean,
nucleotides, not for my proteins. Nope. Mm-mm.
I started thinking if I could spell Angie with amino acids. I think I can.
You
I
can.
can. Yeah,
I think
I
you can.
can.
Oh my god.
There is ANGIE. Yeah.
Yeah. Yeah.
Yeah. That's great. So everybody, what we're talking about here, this is getting, sorry, I didn't mean to get so deep in the weeds, but codons are basically the genetic code. A codon is 3 RNA bases, so ATCG, together, and that unit of 3 encodes an amino acid. And sometimes, as for arginine, there are multiple combinations of these codons that can encode arginine. So in this case, they're basically saying that because somebody chose, and in this case, what chose it was Mother Nature. But what somebody chose 2 arginine codons that were CGG in a row was like somebody, it's like Picasso signing a painting or something. And I just think this is like,
it's just so random.
Part of me is kind of disappointed. I never thought about that. I'm such a bad cloner. I would have loved to put like all of my energy into making some sort of non-coding thing that spelled Angie was here. Like, this is Angie's virus.
Oh my God. Yeah. Like it would never have dawned on me to even do that. But like I don't know, like what if you were trying to make a virus, would you pick something that would you pick codons that were not very represented? Because that tells you that that's probably they're not ideal, right?
No, I would codon optimize it for my expression
Exactly.
system.
So that to me says that, I mean, it is probably just Mother Nature, because if you were trying to actually make this work, you would pick something that wasn't a signature. You'd pick something that's actually sensible, based on your research. But
Yeah,
I mean, I might be
not
wrong.
to be too annoying, but would you pick something with such high CG content also?
Right, things like that. Like you would probably optimize the hell out of this. And so this, I mean, not that anything needs to be optimal to exist, because that's,
Right.
evolution for you. But like if we were doing this, if somebody who had knowledge, they would go for what is, the highest likelihood of success, and it wouldn't have been, like suboptimal codons.
So not only that, Juliet, 2 CGG codons in a row. And you know what else? Oh, I talked to Vincent about this. Guys, you're going to love my Rasmussen Retorts episode with Vincent Rackaniello, where we're talking all kinds of shit about the cloning that has been proposed for all of this lab leak stuff. But that furin cleavage site is, if it were cloned, it's cloned in 2 positions out of frame. I asked Vincent what he would say about that being normal, because Matt Ridley's co-author, Alina Chan, has asserted that it's very normal to routinely clone things in out of frame. And
oh my God. And they released this.
Vincent
That's so
said, like,
embarrassing.
he said that he wouldn't allow like a graduate student who brought that cloning like plan to him to even do it.
That's so embarrassing. Like, no, I'm embarrassed for these people. Like, really, it's out of frame.
It's yeah. I mean, it's inserted out of frame. But like the furin cleavage site itself is in frame. You know what I mean? Yeah. But it's like, why would you actually do that? Like, there's no reason to insert an insertion out of frame. I wouldn't do that, because that's just asking for trouble with my cloning skills.
Yeah,
I mean,
like, why would
I
you add this extra
doing it by the book.
Yeah. That's interesting. Wow.
Juliet, this has been almost an hour now has flown by.
Oh my God,
so
yes.
We usually try to
I hope people watched this.
People have been watching on Twitter. We've had steady increases. We have 530 people watching right now.
Are you serious? And that's exciting.
Yeah.
Oh wow.
Yeah, it's really exciting. I'm really grateful for everybody watching, and I really hope that these types of discussions are helpful for people. Like I was saying a little earlier in the show, one of the reasons like why I'm really trying to emphasize doing this is just that a lot of this information it's a lot, and we live in like a high information overload environment where there's a ton of shit to pick through. And I don't know about you, Juliet, but well, I do actually, because we've talked about it. Everybody watching probably feels the same way. Like you feel overwhelmed most of the time these days.
Yeah, very much so.
And I just thought that one way to help people make sense of at least the corner of this that I know and that you know is just to have us like have a discussion about it that people can access, and like that might actually be somewhat entertaining to watch. I like to think that we are entertaining. We've always found each other to be incredibly entertaining.
Yeah. We can entertain
Um,
each other.
so, I'm really thankful and grateful for you coming on, Juliet, and for
And thank you for
everybody.
having me. I've had a lovely time. This has been great. And I think you're doing a great job, like really bringing information to people that is accurate and also easy to digest. So, keep doing what you're doing, Angie. Like, you're doing a good job.
Well, thank you, Juliet. And I hope that you'll be able to do some more of it with me because I think that, you're excellent at doing this as well. And, you know, as much as people probably also like to get some fashion criticism and some petty cheap shots at like all the people that I don't like, they also like to hear from people like you who are more professional about things.
Oh, you
And
think? No, I'll be the same way. So it's like, no.
no,
No, I'm
but
kidding. Okay, I won't make fun of people's fashion, but probably every other thing. So,
yeah, I mean, I think that it's just great to be able to chat with people like you, Juliet, as well, who I've known for a very, very long
yeah,
time
it's
and
been
is
a
one of
long
my
time.
closest friends. And being able to, just talk about even just what we love about our profession, as well as everything that is going wrong with it right now, is really just helpful for me. And I hope that it's also helpful for a lot of the people who are watching too. So
I
I
think
hope we get
so.
to do a lot more of this.
Me too.
Jessica Malati Rivera will be back next week. She's on a, like I said, well deserved vacation this week. But we will be back. Maybe next week we'll actually have shots. And then Juliet and I will be back either here or in some other form, I think, very, very soon. So thanks so
Agreed.
much for joining, Juliet, and have a wonderful weekend. Happy
All right.
Easter
Take
to
care,
all of those who
everybody.
celebrate.
All right. Thank you, Angie. You take care.
Take
All right.
care. Bye
Bye
bye.
bye.